Let's talk about a famous theorem that's very helpful for evaluating limits. It's called the Squeeze Theorem. For the Squeeze Theorem, you work with three functions. They don't necessarily have to all be different. You have f of x, g of x, and h of x. If you know that f of x is always less than or equal to g of x is always less than or equal to h of x, and the limit as x goes to a of f of x and the limit as x goes to a of h of x both exist and are equal to each other, then you can conclude something about the limit as x goes to a of g of x. Namely, this limit exists and will have the same value as the limit of f of x and the limit of h of x. There are a lot of symbols and functions in the statement of the Squeeze Theorem. The more you work with it, the more you'll get used to what it says. This theorem can be illustrated nicely using pictures. Let's look at the graph of the cosine of 1 over x. As x goes to 0, the function oscillates more and more rapidly between -1 and 1. So much so that as x goes to 0, this function does not have a limit. Let's look at the graph of x times the cosine of 1 over x. Because cosine of 1 over x is always in between -1 and 1, the graph of this new function will always be in between the graph of y equals minus x and y equals x. So even though this function is oscillating more and more rapidly as x goes to 0, it will still have a limit because it is squeezed in between the graphs of these other two functions.